Thank you all for joining us to our live webinar. Today, we'll be talking about harnessing AI, accelerating PCB design and manufacturing cycles with Macrofab and Quilter. Now I'm going to pass it off to Chris Church and Sergey Nestorenko. Chris Church is the co-founder and chief product officer at Macrofab, and he has been 20 years in technology development and leadership and the CEO of Macrofab. And Sergey is the CEO of Quilter, which builds AI-powered PCB design software. If you have any questions, please feel free to ask them in the Q&A section, and we'll have some time at the end to answer these questions. And with that, I hand it off to Chris and Sergey.
Thanks, Pamela. Go ahead and hop onto the agenda. Next slide. So today we're going to talk about some of the, kind of set the stage here for the challenges in PCB prototyping. We're going to learn a little bit about Quilter and Macrofab, the two companies hosting today. And then we're going to have a conversation here around some of the challenges and how AI can really help to improve those. And then we're going to have the opportunity today for the audience, you guys to ask any questions of us. So we'll go ahead and move forward. All right. So when we think about the challenges, in traditional PCB prototyping, right, there are 4 or 5 key areas that we're thinking about. One is, for a lot of companies, the actual act of going from a schematic electrical work to a functioning board design does require some skill and some experience, and a lot of companies have greater requirements for that work than they have skilled staff available. And when we think about, kind of bringing in, newer people that may be less experienced, that can have an impact on the manufacturability and the cost to produce that product. But when we look at the actual work that goes into designing or laying out and routing a PCB, the bulk of it is not actually critical thinking, right? It's a lot of passives, basically connect this to that, make room here and there. And that's a lot of skilled time being used on unskilled work. During that design process, if we don't have feedback from supply chain and manufacturability, we're going to run into 2 real issues going into production. One is whether or not the supply chain can meet our production needs, whether it's component availability, lead time, or pricing. And secondly is whether or not our design decisions are going to cause issues with how long it takes to produce our PCBs, the fabs themselves, the lead times, the costs involved in that, and potentially whether or not the manufacturing processes that we're going to require are going to be able to generate the yield rates we're thinking of. So just kind of set things up, I think we recognize there are about 4 key areas that we're going to be thinking about as we go through this conversation today. And that's kind of where we are. So Sergey, you want to tell us about Quilter?
All right. Yeah. Thank you, Chris, for the introduction and for having us here. So Quilter, we're basically about doing layout. So we focus on boards that are meant for prototyping. And what we try to do is we try to give a dedicated layout resource to every electrical engineer designing schematics. So there's a few benefits to accomplishing this. As Chris already alluded to, layout resources tend to be scarce. Finding someone to do the layout, they might already have a lot on their plate. They might be busy with other projects. You might have to outsource and set up contracts. It takes a lot of time. And so with software, that's obviously not the case. It's infinitely available and scalable and ready to go for you every single time. We also at Quilter focus on not just kind of what people would typically think of PCB automation being like basic auto routers, but we focus on the entire stack, right? So we focus on defining where the components go, what the floor plan is going to be, what the stack up's going to be, which fab we can target, and what rules we use, calculating all the impedance control concerns and things of that nature, all the way through final DRCs and validations. And the kind of third main benefit of all of this is that this really helps our users and customers supercharge their exploration and experimentation, right? Where you're going from taking weeks to do a single board layout to getting hundreds of layouts in an hour, being able to tweak something, do it again, being able to tweak something else, do it again, make the board smaller, see if it fits, do it again. And so experimenting with what layouts come out very quickly is very powerful in this context. So the way this works is quite similar to existing processes that folks already have. So, it's typical for especially someone working at a big company to, build out a schematic, say an Altium, and then to request layout resources from an internal team or from an outsourced team to then do placement and routing. And of course, as we've discussed here, it takes a very long time. So with Quilter, the only real difference is instead of emailing those design files, those schematics to somebody and saying, hey, could you please do this, and waiting, you basically just drag and drop them to a website. And then that's where Quilter comes in and reads the CAD files, does the layout steps that we already discussed, does the validations, and then gives you back the same CAD file you put in, but with the layout already completed. And so then you're back in exactly the same process you would have been to review the layout, generate manufacturing files, and pass it off to Fab. And of course, the focus here is just on speed. So if we can get this done in a few hours compared to a few weeks, that's the real benefit we're going after.
Thanks. And I think Quilter's a really cool tool, right? I've had a chance to talk with Sergey and the rest of the team since they started, and it's just been amazing what they're able to do with this. I wish more of our customers would use tools like Quilter. It would make our life easier. So as to who we are at Macrofab, we are a new way to build electronics, right? We have a platform that enables engineers and procurement teams to have real-time visibility, transparency, and control into their manufacturing production, whether they're dealing with a few prototypes or full-scale production. We enable our customers through our manufacturing platform to get instantaneous pricing and then to access the resources of hundreds of different factories around North America that are able to match the processes, tools, and capabilities necessary to build their products effectively in real time and leverage an entire ecosystem of manufacturing resources without having to go create all of those relationships and manage those individually. One of the things we've recently come out here, since we're talking about AI, is our new AI system that is powering our platform. It's called FabIQ. It's really focused in three core areas. One is around the PCB fab itself, the ability to instantly price up to 95% of the fabs that are out there today. We do have some limitations. There are a few things that can't be instantly priced, but for the vast majority of products out there, our FabIQ system will automatically price the PCB fab at any scale. Secondly, is around the supply chain. FabIQ is able to look at your bill of materials, automatically identify out of stock parts, and automatically identify form fit function alternatives that are readily available and potentially have better prices. Then the third key area it focuses on is on the manufacturing process itself and the cost of doing that. It will, as you look through different scales and volumes, it will automatically identify the best processes to build your product at the right price, identifying the right tools, the tooling, and any changes that need to happen in that process from machinery to people, et cetera, to identify the best way to build it at the particular volume you're at, saving customers potentially thousands by trying to put the wrong size production and the wrong process to the wrong facility. And overall, what that enables us to do is to really accelerate understanding the true cost of your product, getting it to market faster, and making it far easier to manage than ever before. All right, so we're going to go to some Q&A here. So Pamela's going to lead us through, and she got some hard-hitting questions for us today, right?
Awesome. Yes, let's get started. Thank you for the intros on both Macrofab and Quilter. So many of the challenges cited at the beginning of our conversation, extended parts, material lead times, bottlenecks in design and manufacturing resources, manual repetitive design work, they aren't new. Why haven't they been solved yet? And how does AI create new opportunities to address them?
So I'll kind of kick this one off, but Sergey, I think you've got a lot of insight on this as well. But one of the things that really stands out to me in particular is the lack of context, right? So we have a schematic engineer thinking about how the electrical engineering part of this design will work. You have a routing and layout engineer thinking about how to fit all this within the space constraints they have. You have a purchasing person who has to go and buy this board. You have manufacturing engineers and people on the line. And every time there's an issue, we don't understand the cause of that. Why was this choice made? Right? You know, if we can bring context, if at the design side I can get context of what manufacturing will think of this and how my design decisions will impact that, and if at the manufacturing stage I could get context, or even the procurement stage, why was that part chosen? What are the critical attributes of it when I'm thinking about an alternate? That seems to me that that's a pretty big cause of a lot of these problems that we see every day. We spend a lot of time trying to determine that context. How do you think the AI can help with that?
Yeah, I think there's a lot of potential here. I mean, just to add to the list of issues that you enumerated, like zooming in specifically on even schematic and PCB design, one of the issues that we certainly run into all the time, and I think has plagued attempts to automate design, is the fact that schematics don't even contain, in some sense, rigid information, right? Like if you just take apart a schematic file, you really have just a bunch of blocks with presumably part numbers, or maybe something that says R1 100 ohms shrug on it, and that information just gets passed as raw, almost graphics to the layout person, and then of course that to the manufacturers, and then to everything that you're talking about. So I think there's a tremendous potential to kind of rethink, now that automation is becoming possible and that AI is kind of encouraging automation to happen, giving more information to the automation so that it can actually make intelligent decisions. Without the information, there's nothing automation will be able to do. So I think there's a lot that AI will be able to do. So I mean, of course, on the layout side of things, as we give AI the ability to know that we're not just connecting dots, but we're dealing with high-speed signals or high currents or so on and so forth, it can then pull on the tools that exist in the form of physics simulations, and then solve the board layout until the tools kind of give you a pass. And so that'll make a much more usable layout than just a simple autorouter that connect the dots. I think AI also has a lot of potential to extract that information more automatically. So what I mean is asking designers to go through and populate everything by hand is very, very painful. But like LLMs nowadays are getting decent at reading data sheets and extracting some information automatically. And so there's probably a lot that could do. And I'd love to learn more about the what information could be passed from the design side to the manufacturer to make it more helpful for your end of things.
Yeah, and I definitely want to answer that, but you brought up something very, very interesting there about using the AIs and LLMs to actually extract information automatically. And I've seen in some other cases there are tools where we're asking the designer to quantify a particular circuit or submodule in a schematic and say, well, here are my inputs, here are my outputs, here's the voltage that's required. And I think that that's a really interesting concept to be able to say, hey, look, instead of asking the person to define that, go ahead and just figure it out automatically. If you have the part number, if you can get the data sheets, if the LLM can understand that in context, I think that's a really, really cool capability. And even if it's not done at the very early design stage, being able to access that kind of resource at the manufacturing stage, because that, speaking to that end, to the challenges we face there, that context is key, right? I know I said that at the very beginning, but we're faced with we have to make a decision around a change in the process or a change in materials because something's unavailable or it's not working well. How do we get that information today and be able to act on it quickly? So that's, from a manufacturing perspective, if that question is happening during production, the turnaround time on the answer has to be in minutes, because you're potentially going a line down or you're going to have yield issues. If it's happening in the quoting stage, I've seen these sort of questions and answers go back and forth for weeks on end. Right. Well, this is kind of what I intend. Maybe try this. Think about that. And if we could reduce that time, and get more context more quickly with a better understanding of how to meet the customer's needs, I think what we'll see there is a much faster turnaround on these and a much lower cost to produce as well.
Awesome. Next question is, how important is the integration between design and manufacturing in reducing time to market, and where do you see room for improvement?
Sergey, do you want to start this one out for us?
Oh yeah, absolutely. I think one funny thing that we see is like when you start designing a board, the first question you actually ask is who exactly is going to fab it and what stack up is it going to be? And can I get them to commit to those materials, that stack up, the fact that it's available, double check my impedance calculations, whatever else. And then you go through this process of potentially taking weeks or a month of doing a layout. And then you might find out that something changed, right? Some material went out of stock or something like that. Or for whatever reason, procurement is asking you to go and use a different fab or whatever it might be. And the process of like, oh, okay, no problem, we'll just change the stack up and change the design. Well, it's not that easy. It takes a very, very long time to go back and do that. So I think that's kind of one really obvious place is, automation basically gives you a free ability to explore a lot of options at the same time, right? So as a designer, you focus on the schematic and then you just simply ask the question, well, what all stackups could this be made with, right? Let's explore everything from something simple like 4 layers in a large board to more complicated stackups and different materials and weigh the trade-offs. And then giving you that ability to generate all of them automatically or regenerate them quickly if you have to, gives you kind of flexibility and resilience to a sudden change. So if their fab comes back and says, hey, we don't have that material in stock, we have this replacement, and it's off by 10% in the dielectric constant or something like that, no problem. You just regenerate in an hour, review your results, and you're good to go. I think that's a really obvious one that we think about. I'm curious to hear, Chris, from your perspective, what else you're seeing.
Yeah, we certainly have the stack up challenges, and then thinking beyond just, the fabricating of the materials and making sure they're, we typically run into a lot of first pass yield issues, especially with prototypes and early run productions, because a lot of times the engineers don't have visibility or don't have awareness of how their design decisions impact the manufacturing process. And one of the things I'm thinking here is, just at a very basic level is thermal challenges, right? If I'm running a high copper thickness board, I'm putting a lot of very dense components near each other along with this high copper thickness, there are going to be a lot of challenges getting that recipe just right. And I've even seen it where some boards have to be hand assembled because a machine can't get appropriate clearances between components to place them. And they're like, well, why does it take them so long to build this, right? Well, this design decision here has said for the particular machines we're using, right, we can't utilize those machines for part of this board, right? And that's going to have, in addition to time, it's going to have yield issues. One of the other things we have there is also thinking about how we verify an effective design, right? An effective assembly, I would say it would be more accurate. If we go back and we say, okay, we put all the parts on this board, the solder joints look good, x-rays pass, right? What is the easiest and fastest way to verify that was all done correctly and the product is going to work? That's another thing that I think having that integration at the design phase, do you have the right test points? Are they reachable? Are they laid out in such a way that it's cost effective to produce a fixture for it? Those are all the kind of things that we tend to think about, and that's where we see a lot of gaps as well. We kind of see consistency, and it's interesting. This is one of the very interesting things for me. It's consistent across engineers, right? You'll find even within a company, a certain engineering group will have a lower first pass yield than other groups in the same company, producing very, very similar products because they make different design decisions that they understand, they're familiar with, they use a particular pattern. Well, getting feedback to say, hey, that pattern you use is going to reduce the manufacturability of that board and increase the cost, I think would be huge for a lot of those engineering groups.
Chris, I'm curious, like, do you think on the manufacturer side, it'll be possible to, make an API call or automate the question of looking at a layout and predicting those issues, and in particular with time, right?
Mm-hmm.
Like, I'd love to be able to, in the design phase, constantly query an API says, how long is it going to take? How long is it going to take? And just optimize that and just do whatever we have to do to make that be 1 day, right? Or if that's even possible.
Oh, I think that's an excellent question because that is something that has been important to us. We are a platform at the end of the day, so a lot of people interact with our platform on the web through a user interface. But being a platform, we are also an API first company. So if we can integrate with the tools people are using, if they can connect to our APIs and then say, quote this, identify issues, right? That is really part of the goal we're working towards. And really making that kind of feedback available in tools. We've done that in a few places already around the price to manufacture and the lead time to manufacture. But I think as AI becomes more and more integrated in this process up front, in the pricing and the suggestions of what you can do with the design, like we've done with FabIQ. I really want to expose all of that to the tool chain, because if even if the customer doesn't manufacture with us, if they have a better, more manufacturable product, I think everyone benefits from that. So that is definitely right up the vision chain that we have here, and so I think I would like to see our tools doing that in the future, is using the two different AI engines to actually communicate with each other and each solve their own individual problems, but taking feedback from each other.
Yeah, I think it's a lot of places, even outside of manufacturing PCB, are headed in that direction of like collaborative agents discussing with each other. And in particular in this problem, like if you can provide a score that says this is good or this is bad, or it's slow or it's fast, or try this instead, that's a very easy signal for the design agent to kind of take in and consider. So that's an exciting future for sure.
Yeah. I look forward to that future.
And to follow up on that, how can companies ensure that innovations in AI-driven PCB design also translate into efficiencies on the manufacturing floor?
Yeah, that's where I would kind of reflect, what we were just discussing there, right? If that AI design tool can take feedback from the production system and say, hey, here's what we know, right? Here are, kind of huge issues we're seeing in other similar designs to yours. And here are the specific components that are having problems. Here are the specific processes that are being challenged by designs like this. Being able to give it clear guidance. We can't necessarily say, here's how you fix the product, but saying, here's where we've seen issues before. And, here's how we think those issues will impact the producibility. Being able to feed that all the way up to the design side will greatly reduce the time to market and the cost to bring that product to market. I can't stress enough how often we actually see, customers, getting kind of locked in that early EVT and DVT phase where their yields are like, 50%, 60%. And they're like, why can't we get past this point? Right. And you have teams of people who are looking at it together and saying, okay, well, try this, try that, right? What if we could run those experiments automatically during the design phase So you get, 90% of that value before before you're out there trying to actually build it and your schedule is at risk.
Now, what are the key trends in electronics manufacturing that companies need to prepare for to stay ahead in the next decade?
From my perspective, there's one that I think is we're seeing moving this way a lot, and we are concerned that some of our customers are getting caught off guard by it, and it's going to potentially get worse. Is the trend of the supply chain itself to shift its manufacturing capacity to higher value, newer technology components. And you'll find that there are designs that have been around for a while. And you have customers going, well, hey, this has been a low cost design to produce for a long time, but the price keeps going up, right? Why does that price keep going up on me? Well, the supply chain is telling us they're less interested in producing those materials you're using, right? And with the way a lot of the automation and the machine technology is going on the manufacturing side, one of the things that we're seeing is the more we can switch to smaller package size, slightly higher density, little more complex designs or components, the more we're able to take advantage of automation. There haven't been the same sort of advances in equipment and machining over the past decade around some of the larger and through-hole components, et cetera, that a lot of traditional designs have relied on for a low-cost input. But now we're seeing the machines are getting faster and better at smaller packages, kind of chasing that supply chain market. And even though it seems on the outset that sometimes these components are a higher cost than they might be currently paying, their total cost of production and the total cost of ownership on that product actually goes down rapidly over time because it's more able to take advantage of that automation. And we're going to see fewer and fewer supply chain issues with those particular customers as they switch to those newer technologies. And those are some of the things I'm seeing. Sergey, are you hearing anything out there from your customers and seeing anything that some trends that might be impacting them?
Yeah, I mean, I think for the most part, Chris, I have to defer to you on this one as the expert. What I'll say from the perspective of a designer myself is that at least just directly from my own experience, it's just really important to get educated on what's happening at the factories, right? In the extreme cases, like I've met with electrical engineers who are, senior engineers at large companies, to whom it's not even clear if you can make curvy traces or if you must make octilinear traces all the time. Which shows a large disconnect from even just understanding like how the manufacturing process works. So like personally, I've taken some fab tours recently and just seeing all the new stuff that's available, the semi-additive processes, the super high density stuff that's available, the new materials that are coming out to support higher frequencies, just being aware that those tools exist is probably the single most powerful thing as a designer for me to then to be aware of, so that I can make use of those tools. And right now, I don't see a really good way to gain that information other than making best friends with your fabs and your suppliers and going to their facilities and touring and asking a lot of good questions. So that would be my recommendation and something we try to do.
Yeah. So what's the answer? Curved or octilinear?
I mean, in my opinion, the only good reason that remains today to continue using octilinear traces is that CAD software still works more smoothly with it. So even if Quilter automates the design for you and produces octilinear, and you want to modify a little bit, it's a lot easier to do that, to like drag a trace around if it's octilinear than curved. From a first principle physics perspective, I think every single trace should be smooth.
So that's more of a tool problem than a manufacturing problem these days.
I think so.
Do y'all see any challenges or limitations in adopting any of these trends that other companies maybe should be mindful of or aware of?
One of the challenges I've seen, and and I think it's actually, pretty well fitting for today's conversation and guests today, is a lot of companies that we're seeing using some of this older technology that is requiring more labor and not able to take advantage of as much of the automation, is that they don't necessarily have the skill on staff, right? Like I mentioned earlier, we see particular engineering groups within companies, kind of having repetitive issues. You develop a certain process, a certain technology, and if you've been doing it for 10, 15, 20 years, you're kind of in that. And it's hard for some of these companies to just go out there and say, hey, let's just try to do the latest thing. Let's try to utilize the latest technology. Let's understand how this will impact our manufacturing costs. Without a tool that helps them do that, they may not be able to actually go out there and get those resources and move on that very quickly. And then they end up having to go to a third party, say, hey, can you upgrade my design, right? I don't have the staff in-house.
Great. How do you see AI transforming the PCB design and manufacturing landscape in the next 5 to 10 years?
Sergey, I think you're the expert on the first half of this one. So
Yeah, I think I mean, certainly on the design side, I think there's going to be a large change. I mean, we were just at PCB West, last week or a couple of weeks ago, and the keynote address was specifically on this topic of what's going to happen with AI for PCB layout and how is it going to influence everybody in that room. And the consensus that the speaker gave was that 7 to 10 years you should expect it to be largely or fully automated, and with incremental steps until that phase. And I think that's going to look like a lot of different interesting things, right? It's not just going to be layout, in my opinion, right? There's a lot of companies, even outside of Coulter, that are focused on different angles at this. So, for example, there's companies who are betting on schematics being actually written as hardware description languages, kind of like the way that chips and FPGAs are designed rather than schematics, which is really interesting. There's companies that focus on allowing people to draw a block diagram, like a high-level description of, I want a general microprocessor, a general temperature sensor, and a general screen. Please hook it up for me and give it to me, and have that produce a valid schematic, right? That's really, really interesting. Of course, folks like us on that side of taking a schematic and then automatically producing it layout, as we've already mentioned. There's also companies focused on part selection, right? I think we had this thread earlier, Chris, talking about, oh no, like a part's out of stock, and that's going to hold up assembly. What do we do? Can we swap it? Is it allowed here? What are the tolerances? Could we quickly redesign for a part that we do have in stock, or maybe just a different package that we have in stock, or something like that. And even after fabrication, I have friends that are creating companies to automate at least the first stab at firmware design, right? Like reading a giant PDF for a part, figuring out what all the register are that you have to drive on it, and then giving you some basic C for your microcontroller that exercises those that you can then put together. So I think every little piece of this flow is going to get at least Copilot tools to make you a lot more efficient, if not full automation as a first stab.
Yeah, I was thinking about that when you mentioned using HDL to define, higher level circuits. I'm thinking to myself, that sounds like, if you're doing that, like GitHub Copilot could probably, come in and be very, very handy there, assuming it has enough, reference information to start with. But
There's actually, just to fill in on that real quick, one of the most successful applications of like language models are very specific to specifically language problems. So for layout, typically they don't really work. But one of the most successful applications of language models to electronics is specifically in generating Verilog and VHDL. There's a great paper, I think, out of NVIDIA that quantified like hundreds of different HDL design problems, and the Copilot nailed like 70% of them on the first try. It's pretty good.
Nice. I think we're gonna start to see a convergence there, because I know, hardware as a language, started, kind of popping up and being, more popular over the last 5 to 10 years. But maybe it's the combination of like the Copilot style language models that'll help really bring that into the mainstream for more designers out there. One of the things that we're seeing on the manufacturing landscape, and where I expect to see some changes, there are kind of two or three key areas that I think about where AI is becoming, more and more valuable in manufacturing. The first key area is really around optimizing the process execution. So we think about scheduling of similar work, being able to automatically identify shared attributes of different products so that we can reduce changeover and reconfiguration of the process itself. That's one area. And I think the conversation we often have internally is like, effective manufacturing scheduling is a great PhD topic. But it's really hard to build software to do that perfectly. And it's really hard even as a human to do that perfectly. But I think AI has the ability, whether it's a machine learning or, some other form, to come in there and actually optimize that scheduling around efficiency and reducing issues by looking at some of the shared attributes. Another key area that I'm starting to see some motion in, and I think it's going to be really, really big for us in manufacturing, is automatically diagnosing defect causes. If you're sitting there and you've got a product that's, let's say it's an ongoing production run, maybe hundreds of thousands of units over the course of a year, kind of a constantly running manufacturing line. Well, every day new problems are going to pop up in that process, and being able to, because today, depending on where in the process that problem is happening, it can take an hour to 5 hours to diagnose the source of that problem and figure out where you have to go back and make adjustments in the process. And if AI can come in there and say, look, okay, this is where it's happening on the board. This is the particular component that's being impacted and is failing test. And let's follow back through the chain of events and say, okay, we believe it's a temperature profile issue at the oven. I mean, that can save tens of thousands of dollars a month for manufacturers, and potentially, reduce the risk on the customers for that coming out. So those are the two primary areas that that I'm particularly interested in, we're seeing a lot in. And that third area, right, which is one we've already been discussing, which is how do we utilize AI to make the product more manufacturable before the manufacturer ever even sees it.
Chris, I'm curious for you to elaborate on this perspective a little bit. Like
Mhm.
one of my, my biggest like sweaty palms moment as a designer is clicking buy on the manufacturing process, right? And the fear is always the board's gonna show up on my desk. I'm really excited. I'm starting bring up, and then something goes wrong and bring up, and it's not clear what. And that is probably like, it's, when you bring up a board of any complexity and it happens within a few hours and it works, that's a surprise. That's a magical thing. But now, how do you know where it went wrong? Like, did I make a schematic mistake? Did I make a layout mistake? Did the manufacturer accidentally swap layers? Did they use the wrong material? Was it an assembly? Is a diode backwards? Where do I even begin? Like, how do we stitch all that context together and make that smooth?
Yeah, and that is that thing I'm thinking there about on the defect discovery, because typically how that works today is you call up your manufacturer, depending on, some engineers will say, well, maybe it might be on me, let me go figure it out. But most of the time they say it doesn't work, figure it out. And you got a manufacturer sitting there looking at it like, oh, so I got to ship the boards back to me, right? I have to create a debug map first and foremost for this product. And maybe even the designer doesn't know, what to tell me to build this debug map. So we're gonna have to go sitting through here poking around. So, one of the things that kind of pops into my head, debug map is critical, right? If, you know, region X, net X on this board doesn't work, how do I go backwards from the physical product we have through the different constraints in that design to figure out what's all related to this particular area? So if AI can come in there and say, okay, here's your debug map automatically, right? And say, if you tell me which component is not working, let me tell you all the related components and potentially the most common defects given those types of components that could happen in the manufacturing process. So if we can eliminate that very, very quickly and, establish, are there any obvious manufacturing defects? No. Okay. Is there a design defect? Well, can we go test that? Can we simulate your design, give it this input here that, on your test bench, your voltage, your power supply is actually operating at 11.9 volts, not 12 volts. How does that impact the function of this product and so forth? If we can do that very, very quickly, I think a lot of the fear and a lot of the risk goes away for both the designer and the manufacturer in that case.
Now we have a follow-up question from the audience. Tapan asked, if I am a small PCB manufacturer, how do I leverage all the advances in AI technology?
That is a good question. So I'm assuming we're talking about as an EMS company, not necessarily a PCB fab. I think where we are right now is there are a lot of forward-thinking companies who are developing technology in-house for their own utilization. And we are within a few years of those products being commercialized and sellable to the larger industry. So I think today there aren't a lot of options. There are a lot of startups, there are a lot of products out there that are coming out there, and I would say look at those startups in this space. Look at who is investing in that and looking to build a product in that space, and be willing to be an early tester and partner for them. But if you're looking for something kind of off the shelf, like boom, let me plug in, the AI plug into my MES system here. It may not be ready yet, but I think if you look at the startups and if they're looking to be solving a problem that you're having, reach out to them and say, hey, I want to be a beta tester. I want to be an early customer. I really want to be part of this. They're going to be they're going to be game for it because they're looking for customers, they're looking for feedback and product validation, and that will help you get ahead of your peers, right? And you'll be earlier on that train than everybody who's waiting for that plug-in for their MES system.
What new skills do you think engineers and R&D teams will need to develop to stay competitive in a world increasingly driven by AI and automation?
I'm gonna let you start this one off for us, Sergey. I think
All right.
you
happy
spend a
to.
lot of time working with engineers directly, so.
Yes. Yeah, I think there's a few things to say here. I think one kind of immediate thing to start doing is that one of the big shifts that's happening because of AI, and not necessarily because of AI even that's meant only for electronics, but just AI in general, is that like creating automation, even just programming, right? Writing code can now happen in a standard language, right? So you no longer have to learn C or Python or Java to write code. You can just write English and then effectively do the same thing. And so that means that a lot of people who didn't previously see themselves as software engineers who could write automations and therefore help their company, speed up processes and make them more streamlined, can now do so, right? By effectively stitching together tools, writing out what they want in English and either turning that into code to put together, or I'm sure there are and will be even more tools that you just write little English blocks that then do operations and automate processes. So I think that's one way to kind of stay competitive, right? Focus on where within your company or within your peer set you have processes that could be automated. And then now realize that you have tools that don't require you to go back and get a CS degree to automate them and solve them. The other thing I'll say in general is that, automation, like there's a common fear that people have, like the elephant in the room of, is it going to take my job, right? And I think we've seen historically over and over and over again that what actually happens is that people stay, they go up an abstraction level, overall the output of that company goes up, and the company actually just needs more people, right? In fact, compiling code used to be a manual job, and people argued for a long time that it would never be automated. And of course, now that would be a ridiculous thought. So I would think that with that, the most important thing, the most important skill to have is just to know what question to ask, right? If suddenly something new has been automated and done, where else are there issues? Where else are there bottlenecks? Like, what else should we be focused on now that a new problem or an old problem has been solved? I think that's an important thing to continue to do, and just to be aware that AI is available to help you with that process.
Yeah, I think, Sergey, it's interesting that you mentioned that. One of my early jobs, and I only stayed there briefly because I didn't like it very much, was as a compile engineer, right? Literally writing make files and running the compile at the end of every day, testing everyone's code. Nowadays, we don't even think about it, right? It just happens automatically. To kind of build on what you said there, though, we do hear, obviously in the world, like AI is going to replace people. It's not. I think at the end of the day, what you end up with, to be very specific on that, what's going to happen with AI is people who don't use AI are going to be replaced by people who do use AI. The people are still going to be part of that, but they're really going to be focused on the things that aren't obvious and that aren't, easily filled in, to where their actual skill and their actual experience in that particular role becomes more important than just doing the basic work. We see that in the software developers we have here. There were early concerns. I think one of the conversations we had, like when GitHub Copilot first came out, was we're really concerned that Copilot can write bugs faster than people can debug them. And so we had to get little, because everyone was stretching to use it, and we did a few test projects. And so what we found were the best developers were those that could instruct the AI better and understood the problem space better, so that on the first or second pass, the AI got that particular set of code written properly, right? And so those were things that we looked at. And now we're finding that, kind of across most of the knowledge worker space, right, is the best performing people and the people who meet their goals have started to utilize AI to take off rote tasks off of their plate every day to focus on the things where they can really provide value.
Now, what role does the traditional PCB designer play in manufacturing? And how does this role evolve with the proliferation of AI and automation in PCB design?
So one of the things that we have noticed here is in some in some larger, more traditional organizations, the answer what role the traditional PCB designer plays in manufacturing is none at all. Right? They throw it over the fence. I've finished the design. It's now procurement's issue. Have fun. Let me know if you need any help. But in more forward-thinking organizations and more modern organizations, especially as platforms like ours have come out that enable those engineers to engage with the manufacturing process more easily, I'm going to reflect a little bit on my answer in Q1. They're there to help provide context, right? That, hey, if you're having issues with this, this is what I intended, and these are the things that I could allow. The changes we could allow based on, still meeting the intentions of this product and how it should operate. That we found is very, very critical today. If the tools aren't there yet that are able to communicate that intention and help us test whether a change keeps within the functional bounds of the product. And I'm really excited for things that, Sergey and his team are working on that will let us do that. Without that, the designer is still there today, right? And we really need them involved, especially in the NPI, the I'm using an acronym there, the new product introduction phase of a product where we're first trying to figure out how to build it efficiently and effectively. Having them involved in that process to provide context, provide clarity, and the ability to rapidly make changes is critical for us as a manufacturer. And I think for the company hiring the manufacturer, I think it's critical for them to get to market faster.
Awesome. Now we have the audience Q&A. So if any of y'all have any questions, please keep adding them in the Q&A. Right now we have one question. And it's, how important is vertical integration? Example, one-stop shop solutions in achieving the next major step change in development speed.
So vertical integration, we're thinking like I can read this a couple of ways, right? One would say that, the manufacturer is vertically integrated, i.e. they maybe have a component distributor, they may make the PCB fabs, they maybe do the assembly in-house. I think that from that concept, right, where I go to a vertically integrated EMS company, it can help in a lot of ways, but it can also be very constrictive to you, right? It tends to go faster, right? If you have to make fab changes very, very quickly, right? You get them done the same day, get them on the line. But one of the risks we have in that is your product becomes very tuned for that manufacturer's specific processes, which, if we're doing a lower volume production, and I have a very stable market and a very stable vendor in that case, that may work out for me. But if I'm going to go through a very rapid scaling exercise, that can be an inhibitor for me because I haven't generalized it to a particular, say, a high volume PCBA. Right. If that particular manufacturer isn't really experienced at high volume and low volume fab and high volume and low volume assembly, you may start running into barriers there. The thing that helped you early in the process can now become a risk as you go up to scale. So from my perspective, it really depends on, what is most important for you. Is it important to get to market as quick as possible, or to establish the long-term manufacturability and flexibility of your supply chain? I think that would be the decision I would make on that.
And to follow up on that, how does FabIQ's entry into parts procurement and sourcing contribute to this? And what impact does it have on both prototype and production timelines?
Mm-hmm. Yeah, so we found when we were looking at our, we've run through our platform close to 100,000 products. We build on average for a few thousand customers every year, and a pretty wide variety of SKUs. So what we found is we looked at where people were having most of the delays, going from, hey, I've got a good design, to I want the right price. The two key areas where we found that they were running into delays were, one, that their fab requirements were very, very specific, and they were very unique to them in a lot of cases. And that was triggering a need to go out, find a specific PCB fabricator, understand the pricing that they were going to provide for that particular fab, and then come back and bring that back into the design. And often that changed based on the volume. The other key problem we saw people running into is they made choices during the initial schematic and design phase around parts that weren't available. And they were getting stuck for one or two parts on a very regular basis. This is actually the biggest cause of delays in getting to pricing and manufacturability. So where we looked at there is saying, okay, if we can come in there And, we can say, hey, we understand what parts you want to use in there. Let's come and think about what are the potential alternatives, and not just what are the alternatives, but the alternatives that are readily available and within your price constraints. And looking at that from our perspective, it was really about getting you to the answer of what is the price to build this product, and getting you into your early stages of assembly as quickly as possible. And we found for a lot of our customers, it's taking up to 2 to 3 weeks where they were having to go and resolve those issues with their engineering teams and their peers. To figure out, well, I got these 5 parts. What can I use different? This PCB fab is coming back too expensive. All of those things were taking weeks. And with FabIQ now, we've found that the customers, our typical customer that had these issues before is now getting to pricing within a few hours.
Awesome. And we have another question. Are there specific industries or sectors that you think will benefit most from AI-driven speed in design or cost reductions in manufacturing?
Sergey, I think this is a good one for you.
Yeah, happy to jump in here. So I get this flavor of this question quite frequently, actually, right? Because we're used to segmenting markets effectively by industry, aerospace and medical and so on and so forth. I actually have an opinion that the segmentation will happen not necessarily by industry, but more by job title. So if you think about it, like even, any given company, SpaceX, where I worked for a long time, it designs everything from really simple boards to really, really, really complicated boards. You've got everything from a simple little test switch with a button and a screen all the way up to like a Starlink antenna, right? And everything in between. And I mean, just by the nature of the problem, getting automation and AI to help with something really sophisticated that has tens or hundreds of thousands of parts is just much harder than getting it to help with something that should be really trivial, that maybe is even done on a breadboard today because somebody didn't even have the skills to do basic layout. So I imagine the kind of biggest shift happening first with the teams that are either focused on simpler designs, right? So people who are focused on test boards, breakout boards, basic kind of manufacturing equipment to facilitate, integrations between tools and whatever else. And perhaps also in empowering people that didn't even have the skills to do PCB design before, right? So a lot of our users actually come to us when they wanted to build their first board, and they know how to read and write a schematic, but they have just never used the CAD tool before, and that was a barrier. And now that barrier doesn't exist, it's easy for them to suddenly start making boards, and now they have a whole new skill set that they have access to. So I think we're going to see it in every industry relatively simultaneously, but it'll first happen in the kind of like R&D, early adopter, kind of non-critical path groups. And then as the capabilities are proved out, they'll move up the value chain into the critical path.
Absolutely. And I think there's some similarity on the manufacturing side as well, in that it's a little less about the industries, that those manufacturers are serving, and a little more about, the types of product challenges that people are having. So if I think about how AI is going to where it's going to have the most impact early on in the manufacturing process, I'm thinking, highly complex products. That have a lot of risk surface to them, to kind of figure out that's where we see high cost and a whole lot of labor being put to make sure that they're being built correctly. And then on the other side of that one is the high volume, right? When you've got a lot of product running, you're generating a lot of data, and being able to identify issues in the process, more quickly and before they become much larger issues and potentially shut down the process. We're going to start seeing that on the manufacturing floor, that AI really is going to first really be deployed in those two areas, complexity and volume.
Awesome. So now we're coming up on time. If there are no more questions, we want to thank you all for joining us today. If you want to revisit any of the key points at your convenience, the presentation will be available on demand on our website. And if you'd like this PowerPoint or the recording emailed to you, please send a request to marketing@macrofab.com. If there are any more comments, thank you, Chris. Thank you, Sergi. Thank you, everyone. And I hope everyone has a great Wednesday.
Thank you so much. Appreciate it.
Thanks.